Hi everyone! In this video I'd like to continue solving some exponential and log equations, and I want to get into a little bit messier equations where we'll have to use some of our log properties to help us solve. So we want to be really careful with some of these. Otherwise, our basic strategy is the same. If we're trying to solve a log equation, we would like to at some point exponentiate to get rid of the log. If we're trying to solve an exponential equation, we would like to at some point introduce a log to help us get variables out of exponents. So on this first one, this is looking really promising. They're all log base 3s, so exponentiating with base 3 should help me cancel, but I need you to be extremely careful when you do this. If you exponentiate right off the bat, what you'd really get is 3 to the log base 3 of x plus log base 3 of 2 equals 3 to the log base 3 of 3x minus 1. Things work out beautifully over here. 3 to the log base 3 of 3x minus 1 is just 3x minus 1, but you have to be very, very careful with the left-hand side. You cannot distribute the base of an exponential statement. So here, if we think about our order, when we plug x in, we would take a log, we would then add, we would then exponentiate. So the taking the log and the exponentiating don't happen one right after the other, which means they won't cancel out. So before this will cancel, and in fact generally I do it as my first step, but we'll go ahead and do it now. You would have to combine the logs. The log base 3 of x plus the log base 3 of 2 is the same as the log base 3 of 2x. So the property that says if you're adding two logs you can combine it into a single log is ideal here. Now we have inverses happening one right after the other. So we plug in an x, we double it, we take the log, we then exponentiate because that happened one right after the other. That will cancel. I then need to subtract 3x from both sides. So I get negative x equals negative 1, which means x is equal to positive 1. There's a non-optional check here. This is a log equation. Log of 1, totally valid. Log of 2 is good. Here, if we plug in 1, we get the log of 3 minus 1. The log of 2, again, totally valid. So that's looking good. And once again, if you want to do a more thorough check, you can. We got the log of 1 plus the, log base 3 of 1 plus log base 3 of 2 equals log base 3 of 2, which sounds a little questionable until you think about the fact that the log base 3 of 1 is 0. So it really is a good statement. Log base 3 of 2 equals log base 3 of 2.